Now we are on chapter number 11, which is storage is expensive. One of the more expensive operation in Solidity is using storage, particularly writes. This is because every time you write or change a piece of data, it's written permanently to the blockchain. Moreover, thousands of nodes across the world need to store that data on their hard drives, and this amount of data keeps growing over time as the blockchain grows. So there's the cost to doing that. In order to keep costs down, you want to avoid writing data to storage except when absolutely necessary. Sometimes this involves mainly inefficient programming logic, like rebuilding an array in memory every time a function is called instead of simply saving that array in a variable for quick lookups. In most programming languages, looping over large dataset is expensive, but in Solidity, this is way cheaper than using storage if it's in an external view function. Since view function doesn't cost your user any gas, and gas costs your users real memory. And well, go over for loops in the next chapter. But first, let's go over how to declare arrays in memory. Declaring arrays in memory. You can use the memory keyword with arrays to create a new array inside a function without needing to write anything to the storage. The array will only exist until the end of the function call, and this is a lot cheaper gas-wise than updating an array in storage. Free storage if it's a view function called externally. Here's how declare an array in memory. Here it is. We are defining array in memory. This is a trivial example just to show you the syntax, but the next chapter will look at combining with the for loops for real use cases. Memory array must be created with the length argument. In this example 3, they currently cannot be resized like a storage array can with array.push, although this may be changed in the future version of Solidity. In our getZombie function, we want to return a uint array with all the zombies a particular user owns. Declare uint memory variable called result. Now let's create it. Uint memory result. Set it equal to a new uint array. The length of array should be however many zombies his owner owns, which can look up for the mapping with the owner zombie count owner. Okay. Set it equal to new uint array. The size will be zombie count underscore owner. Okay, so it should be a fixed size, so that's how we can fix it. Okay, at the end of the function returns result as just an empty right now, but in the next chapter we'll fill it. Okay, Now let's just return result. Yes. So let's check the answer. Yes, it's correct. So we have completed chapter number 11 also. Now let's move on to chapter number 12.